Hello, my name is Aaron Snow, and in this video, we're going to try to look at more in depth pertaining to Memristors and Memristor technology. And hopefully, I won't hit my mic too many times. Memristors are a combination of the word memory and resistor. A memristor is a component that was recently discovered. You have all these other components. You have resistors, you have transistors, you have capacitors, you have inductors, you have all these different devices that were created. And this technology has driven today's technology has been driven by these components. It has completely changed how life is on the earth today. By this, we've created satellites, we've created these special rockets, we've sent things all over the earth and to the depths of the oceans because of this information pertaining to electronics and stuff. So any type of component makes a big difference. It is never a small thing because today's scientists can use this information for anything. I mean, they know what they're doing. Most of these people do, especially with something like this. Now, like I said, you got the resistors, you got all this other technology, and together they create computers, they create cell phones, they create clocks, they create robots, GPS computers that tell you where you are on the globe. Anyway, but it's all awesome stuff. So where does the memristor fit into this picture, and what is the memristor for? How does it work? What is it good for? What's the thing about it? Well, for those, I'd like to explain some of this to those who really don't even know what any of these parts do. So I'm going to kind of talk basic. I'm not going to really get too detailed about anything or scientific or use a lot of math. I just want to quickly explain what I see is going on here. So get rid of the memristor thing right there. There we go. Now, number one you ought to know is about a memristor is that it's related to the resistor. And a resistor, as most of you should already know, restricts the flow of electrons through itself. That's what it's for. It slows electrons down. And electrons, if you look at it in the big picture, I think of water when I think of electrons. It's like water flows, electrons flow, and it sort of works the same in a lot of ways. Not completely the same. There's no magnetism with a lot of water molecules, but there is with electronics. But still, at the same time, it's sort of similar. It's flowing water through a pipe. Reminds me of electricity flowing through a wire. So that's what we're going to do here is look at this. Sort of just to describe resistance, we'll draw a pipe, just a regular old pipe. Now, a small pipe will only let a certain amount of water through. A large pipe will let a lot of water through. It's just a natural thing. If they both have the same amount of pressure, they'll let water out at a different rate based upon the size of the hole or the size of the pipe that's there. No, it's the same thing with electrons. The smaller the pipe, the more resistance there is to allowing the water to go through, to allowing the electrons to go through. The smaller the pipe or the more resistance of the substance it is, the less likely the enough electrons will actually go through and leave the battery or whatever your power source is. So it's like with a big bucket, another example is like you have a big water bucket and you got water in there, really good, great drawing right here. You got a little rubber ducky right here. There we go. Like my rubber ducky, sort of. Anyway, if you have a small hole in this bucket, then a little bit of water will come out. And eventually it will drain out. I mean, it's all going to drain, but it's real slow. So you would say that the hole is like high resistance. It resists the water going through it. But if we put a big old hole in it, we'll make this hole a lot bigger, then it's just like going to just gush out of the tank and that rubber ducky will have nothing in it, nothing to float on, in like 5 seconds. That's a big old hole there, and it just all rushes out at once. And so you would say it has low resistance. It does not resist the flow of the water going through it. And that's exactly the same thing that occurs with electricity. Got a battery. It's kind of like the flow of water going positive to negative. A little known fact, electrons actually go from negative to positive. Somebody messed this up a long time ago. I don't know what the deal was, but whatever. We're just going to go with convention right now. But the battery juice, the electrons, will leave the terminals and go through the system. It goes through a wire, and if the wire has low resistance, a lot of electrons will go through this wire. If this wire has high resistance, then very few electrons will go through the wire. Now, most of the time, if you put a wire between two terminals, a lot of it's like no resistance at all, and all this electrons will try to go through that wire at once, and it will melt the wire, or it will be so hot that the battery will actually start to boil. The water in the battery, some batteries or have acid in it, and it just starts boiling, and it gets hot, and the battery explodes. That's why you should never put a wire between two terminals of a car battery, because it's the lead acid battery, and it will go boom. It's a very dangerous situation. Then you'll get acid all over your face, and that won't be very nice. So, we want a resistor in there that resists the flow of electricity. And so most resistors look like this, only not nearly as big, but you have an input, an output, which could be in any, it's not based upon orientation. I could put the input over here and the output over there. It doesn't matter, just as long as electricity is flowing through this device. And this right here is called a resistor, and it's measured in ohms. That's OHMS. And this is important to know to really understand a memristor. I sort of reiterate this. There's a point to all this. A low ohm resistor, like a 1 ohm resistor, lets a lot of electricity flow through it. It's a lot of electricity would just go through the system. If it's a low ohm resistor, low resistance. But if it's a high ohm resistor, say if it has a higher ohm resistor, say if it has 10 ohms, then it restricts more electrons. So not quite as many electrons make it through the resistor. It just slows it down. And sometimes this can heat up a resistor and make the resistor hot, but that's what it's designed to do, to resist the flow of electricity. And so it's very important to have resistors. Resistors keep, your electronic devices from burning up. It keeps the wires from melting. It slows the electrons down. And it's used for other purposes too, but that's its main purpose right there. Now, it's good to have this concept of resistor in your mind to really understand a memristor. Another thing that you need in your mind also, sort of to understand a memristor, is actually a transistor. A transistor acts just like a resistor. That's what a transistor does. And it looks a lot like a transistor or a memristor. It looks a lot like a resistor. There's an input and an output. Electricity flows through the transistor. But there's one thing that's added that's different from a transistor, and it's actually like the third leg. It's the third wire right here. So, and it's made out of silicon. It's made out of different things. It's not made like a normal resistor. It's usually, has other stuff in it, impurities that slow the flow of electrons down. But a transistor has a lot of different types of silicon in it, and it's a very special product. It's somewhat advanced. And what happens is this electric current is adjusted. I mean, this is like a resistor that's modifiable. It's like a An adjustable resistor. That's what a transistor is. You can adjust it on the fly in real time. And instead of adjusting it, manually, you can adjust it with voltage. Say we got 10 volts on this thing. Well, let's say that this particular transistor, if you have 10 volts in it, then it completely opens up the circuit and electrons can freely run through this circuit. It just electrons, it coming from here to there, just freely going through the circuit, and it's all the way open, and the valve is open with 10 volts. What happens if we put 0 volts in this case? No voltage at all. Well, suddenly, this thing right here closes off. And it says, we're not letting any electrons at all go through it. So suddenly, it's like this ultimate resistance. It's like 10,000 or 10 million ohm resistor. It becomes a really stout resistor. Technically speaking, some electrons sometimes manages to make it across, but it's so few, it's like this really big resistor, it's just stopping everything. But if we want to go back to 10 volts, suddenly it turns loose again. It kind of reminds me, in a way, thinking about water again, it's kind of reminds me of a knob, of a valve within a pipe. It's like if this was a pipe and there's a little valve here, and you got this little, and you sit there and adjust it, and that's what it's doing. It's restricting the flow according to how you feel. You want it to be open, and you can set it midway too. You can, instead of 10 volts, you can set it at 5 volts. 5 volts would be midway, and it lets half the amount of water go through it. You're thinking about a pot. Well, it lets half the amount of electricity to go through it. So this is, that's what it does. But of course, if you take the electricity off of it, it goes back to 0 again. So in a way, it's kind of like you have to have your hand on the valve all the time, because if you ever take your hand off the valve, it's like you close the valve. So there's no memory to it. It has no state. It's like you have to control it with voltage, and if you ever take the voltage off of it, it returns to its natural state, which in this case is when it's totally off. So it's like, no, it's not in between. It's not letting some of the current through. It's letting no current through in this case. So that's what this transistor does. So it's a resistor that's adjustable. Well, a memristor is the exact same thing, only there's 2 other things that's involved with it. But it's also simpler in structure. So number 1, it looks just like a resistor. Just like a resistor. 2 terminals, no third terminal, just 2 terminals. And it lets electricity go through it, and it just circles through it, And you think at a set ohms. So this is like a 10 ohm resistor. It's not very strong, but it allows a certain amount of electrons to go through, Okay, say that we want to adjust this. Remember, with a transistor, we can adjust it with a valve of electricity. Well, we can do the same thing with a memristor. And how you adjust a memristor is that you put a surge of voltage. Say right now we have 10 volts going through it, and this is a 10 ohm resistor, and it's allowing a certain amount of electricity to go through. Okay? In order to change the resistor, we'd have to send a surge of volts through it, say 20 volts. All of a sudden, out of nowhere, we send 20 volts, a surge, just out of nowhere. And what this does is it changes the resistance of the resistor. It changes the memristor to a different resistance level. And we surged it with 20 volts. Now this resistor perhaps has turned into a 100 ohm resistor. Why is it a 100 ohm resistor? Because we surged it with 20 volts. And let's say we just put 20 volts into it. We just say, no, okay, we surged it once and that's all we need. Well, that's true. Does this 100 ohm Now, the question is, does this 100 ohm resistor revert back to the 10 ohm? No, it stays at 100 ohms. Again, that's what's special about the memristor. It stays where you put it. Okay, so now it's a 100 ohm resistor, but I'm now putting 10 volts back into the system. Okay, so what that means is less electrons are flowing through it. I adjusted it. I changed it. I changed the state of the memristor. I changed the transistor, the resistor property of it. Okay, how do I fix it? Well, what if I instead of sending 20 volts in there, what if I decided at this point to send negative 20 volts in there? It's like 20 volts in the opposite direction. Just all of a sudden I sucked through it, 20 volts through it. What would happen is what you'd think would happen. It went from 100 ohms back down to 10 ohms. Okay, it's no longer a 100 ohm resistor. Now it's back to 10 ohms because I surged it with 20 volts, negative 20 volts. And okay, again, we surged it. Now we're no longer using it. Well, did the resistance change permanently? Yes. It's back to a 10 ohm resistance, and it stays there in that position. I didn't have to add any electricity to it. If I decided not to use my device, maybe I have a device that has a bunch of these memristors in it, and suddenly I turn the electricity off. I decided to put it aside, and later on I got it back again. I turned it back on. You know what? It's still at 10 ohms, or it's still at 100 ohm resistance. It didn't change like it would with a transistor. Transistor goes back to its original value, but a memristor stays where it's put. And now this has, hopefully you can sort of grasp what I'm saying here at this point. Right now I want to make quick mention of the possibilities of this device, what makes it uniquely special. And there's a couple of things. Number one is obviously it's in memory, because if you can instantly store data in a memristor, it's saying something, because it's better than flash memory. They discovered that a memristor can store so much more memory in such a more dense atmosphere. It's like you can layer memristors on top of each other and make this ultra dense compact memory system that's ultra fast and that is ultra tiny, and you can put it anywhere. You can put this memory inside a CPU chip. It's kind of like having RAM built in to your chip or to your processor or the cache. That's like huge amounts of RAM. You don't even need to add RAM to your computer anymore because it can be all inbuilt inside the processor. That's how wonderful this is, and fast. And instead of like a flash drive or an SSD where there's a certain amount of times where you can write on an SSD or a flash drive before the flash drive quits working, or the SSD, solid state drive quits working. It's not built to be used multiple times. It'll last a while, right? I mean, my computer has an SSD in it also, but it'll last me a few years. But a memristor will last tens of thousands of years. That's what's different about a memristor. It's so much more robust. It's so much more condensed. It uses less electricity, so it's cooler, and so you can stack them together, and it's just better off. And again, you saw the similarities between a transistor and a memristor. And this is the other important thing about memristors. Memristors can replace transistors. A memristor can replace multiple transistors. Memristors can make things a lot smaller for this reason. And notice this. In a transistor, we have an on stage and an off stage. That's usually, and there is in between, but remember, it doesn't stay in between. It's not made to stay in between. It's made really to be on or off. That's how a memristor is set up, because there's no memory to it. But a memristor, you can put it in a zero position. Remember, the zeros and ones, computer-based technology, are binary. binary systems, which most computers are working on or exist on. So you have this 0 1 type of code, you know, in this binary system. But with a memristor, you have 0 1, then you can have 0.5, you have 0.6, you have 0.7, 0.8, or 0.512763 and it's like it's almost open, but you have all these fine coded digits. Basically, it's not just 1 0 state, but it's multiple states. And because it's multiple states, you can record vast amounts of information in one memristor. Now think about how you take this long code. For those who understand binary, how many transistors does it take to store, a 6-digit number or a 7-digit number or 8-digit number? Well, you can store that 8-digit number in one memristor because you can set the memristor at that particular state. For instance, I mean, just to give an example, you can put it in that certain level, and that data is there in one bit of information. I say 1 bit, it's kind of like in terms of memristor, that is 1 bit. You can store vast amounts of information in 1 bit, but this processing or adding that you do with transistors can be done with a memristor. Multiple transistors can be used with one memristor, and so forth and so on. But when you get into that level of technology, now you're no longer thinking ones and zeros. You can now start to consider things like artificial neural networks, because artificial neural networks are these systems where they add up these vast numbers and digits. That's what it does. It adds information. A real simple way. I probably shouldn't go on into this because it probably would take more time, or I should do it in another video. But I guess I can be really brief about this. But an artificial neural network basically taking multiple inputs and then adding those inputs up. It's like this taking the sum of all the inputs, and then there's all these hidden layers or whatever, and then finally comes out with an output. And this creates this tremendous amount of processing or teaching of a neural network system. Is so much more efficient when you have the components that are built for neural networks. And it so happens that the basic component that builds a neural network is a memristor. Your brain cells, your neurons within your mind, this natural neural network that's existing in your brain right now, it's built on memristors. Your synapses are memristors. When a certain signal hits it, it closes the synapses off. When another signal hits it, it opens it up a certain amount, and not just in a binary way, but in a precise amount. It adds signals up. It combines signals together. And that is an artificial neural network or natural neural network at work using a memristor. So it's a completely different technology. It's so far above and beyond simple binary, and it gets the job done quicker than a binary would ever think about doing. So anyway, it just opens a world up for artificial intelligence. It opens up everything for this new technology and more condensed technology, and for terminators to take over the world. But hey, it's going to happen anyway. Whatever. It's going to happen anyway, but whatever. It's anyway. I'm excited about all this, but I just wanted to get this stuff out and say something about it, and maybe somebody will catch some bit of information out of this, and hopefully you'll be as excited as I am. But there's really so much more to it than what I'm saying. There's so many details in it. It can be used probably for any type of thing imaginable. I can just imagine, true interaction between a memristor circuit and your human brain, because they would have the capacity to talk to it and communicate directly to it. You just need the right interface and just insert it into your mind or whatever. You know, you become completely augmented and superhuman. I don't know, but whatever. You know, just throw that in there. Who knows the possibilities to this? But I thank you guys for listening, and maybe if you have any ideas or anything you want to add to this, uh, go ahead and say it, and maybe you can come up with something that I didn't. Anyway, see you later, guys, and I hope this video was informative, fun, and fascinating. Thank you.